So, the topic that we'll be talking about today is energy sources. In this topic, we'll be discussing the main two types of energy sources, that is the renewable energy forms and the non renewable energy forms. So, energy is basically needed to in every field of our life, and for example, it's needed to heat buildings, to make cars move, to provide artificial light, and to make computers work, and so on. The list is endless. This useful energy needs to be produced in controllable energy transfers and in controllable environments. For example, in power stations, a supply of useful energy in form of electricity is produced. The raw materials for energy production are sources, and this is the topic that we are going to be talking about today. Well, these resources, they can be either renewable or non-renewable, but it's very important to note that in both of these cases, energy is being conserved even in the non-renewable form. Apart from nuclear, geothermal, hydroelectric, or tidal energy, the sun is also the source for all energy resources. And these are basically this is basically the renewable energy forms or the renewable energy sources. However, if we talk about the non-renewable energy, then we have a lot of fuels, oils, coals, and other forms or sources. So this is basically a pictogram that shows two types of non-renewable energy sources and two types of renewable energy sources. Solar energy is basically the biggest source of energy, and it's used for solar power generation. Apart from that, wind power and tidal power generation is also renewable forms of energies, and the source does not get depleted when energy is produced. Sorry, when energy is transformed into another form. So, um, as we're talking about the renewable form of energy, there are also two examples of non-renewable forms of energy that are given in this diagram. So the first one is that of coal. There is a miner who's shown over here with a lot of coal, and though its harm to the environment that has sapped its popularity, coal is still used for many purposes, including to run a thermal power plant. So coal, fuels, and oils, all of these are non-renewable forms of energy. As we're talking about oil, it is very important to note that oil is the most common source of energy with wide reaching applications such as in factory, automobile, or power generation. And in most multinational industries, too, the main source through which they are running is oil generation. So this is basically the most common source at energy. This is the most common source at energy with wide-reaching applications. However, the main source of energy, or the biggest source of energy, or the main origin, is that of solar energy. So non-renewable form of energy. Before we get into the other types of non-renewable energy, not the types, but how they're classified and produced in different forms. Uh, or from different ways, it's very important to note or clear the concept of what exactly non-renewable energy sources are. So, non-renewable energy sources are the sources that when they are when that once they use up, these cannot be replaced. That the procedure of energy production, it's not cyclic, it's just one way. However, it's very important to note that this does not mean that energy is destroyed or that energy is being created by these sources. Energy is stored in these sources and then it's converted to some other form, and then instead of getting back to the origin of where it was being stored, of for example these sources, it converts into different other forms. For example, just gets wasted in form of heat energy due to friction or whatever at the end. So that's basically how it is, but still the conservation of energy law holds. So the first example, that is the biggest example of non-renewable energy sources, is that of fossil fuels. Now, what exactly are fossil fuels? Fossil fuels include coal, oil, and natural gas. They're formed from the remains of plants and animals which have lived millions of years ago and obtained energy originally from sun. See, it's very important to note again that this energy was originally obtained from sun. So basically, when a plant or an animal dies, after millions of years, they form fossil fuels, which are then, these coal, oil, or natural gas. So, um, some estimates say that oil and gas will run low early in the present century, but coal should last for 200 years or so. Burning fossil fuels in power stations and car pollutes the atmosphere. However, this threat that is written over here that estimates say that oil and gas will run low early in the present century, they don't. This does not mean much since there are other alternatives that are already replacing these technologies or this way of energy production. So, burning fossil fuels in power stations and in cars pollutes the atmosphere with harmful gases such as carbon dioxide and sulfur dioxide. Well, now what happens is, why are these harmful? We have heard about, carbon dioxide and everything, how it causes global warming, but especially sulfur dioxide, because when it especially uh, reaches the top of the atmosphere, it and towards the clouds, it reacts with the water, and it can basically cause acid rain because water and sulfur dioxide, they can react together to form sulfuric acid. So carbon dioxide emissions aggravates the greenhouse effect and increase global warming, and then sulfur dioxide effect is, already explained over here. It is not immediately feasible to prevent large amounts of carbon dioxide entering the atmosphere uh, to stop that, but less is produced by burning natural gas than by burning oil or coal. So, the amount of percentage or the proportion of carbon dioxide production through burning coal or burning oil is much larger than that of natural gas. Well, the reason is because the coals or the oils, they're formed, or they're made up of compounds that have more carbon content in it. Um, you know, the higher order alkanes or other organic compounds. However, natural gas does not have a lot of carbon content in it, hence the less calorific value too. But still, it's far more environment friendly than the other ones, including coal or oil that we were discussing earlier. So, burning coal produces most carbon dioxide for each unit of energy produced. So, that's again because of the high carbon content compounds that are present in coal, which is to our pro good that it produces more energy content. However, it's also very much harmful for the environment. These are the main basic types of power stations or thermal power stations that are there and which use up coal, oil, or other natural resources or fossil fuels, as I said earlier, to basically produce energy. So, what happens is that these fossil fuels or these fuels burn, and then some medium is heated up, which runs the turbines, and then they rotate, and the energy is produced. Basically, most common form of energy that is usable, electricity, is produced like that. So, nuclear fuels. Now, nuclear fuels are also non-renewable forms of energies, and the energy released in a nuclear reactor from uranium found as an ore in the ground can also be used to produce electricity. Nuclear fuels do not pollute the atmosphere with carbon dioxide or sulfur dioxide, but however, they do generate radioactive waste materials with very, very, very long half lives. Safe ways of storing this waste for perhaps thousands of years must be found. And we cannot do much about the background radiation that is produced because of these reactions. However, um, when the process is happening, in order to protect the user, what they can do is that they can wear lead lined suits or lead lined boxes. So the basically radioactive pollution is not as much as expected. As long as the reactor is operating normally, it does not pose a radiation risk. But if an accident occurs, dangerous radioactive material can leak from the reactor and spread over a large area. So again, it's not as harmful in terms of a constant emission of carbon dioxide or sulfur dioxide, since the radioactive waste materials, they have a very long half-life, so the impact is not very immediate or it's not very constant. However, there if uh, there is a chance of some accident happening, then obviously the accident will be of higher risk than that which will be occurred because of the something related to the thermal power station. So indeed, nuclear power stations, they do require more safety precautions in order to prevent these accidents from happening. So, two advantages of all non renewable fuels are that they're high energy density, that they're concentrated sources, and they're relatively small size of energy transfer device, and that they do not require a cyclic or a continuous way of pumping things. For example, if we're talking about hydroelectric or other tidal forms, that we don't need like a constant maintenance cost. If you want to use you just want one time usage of some high energy value, then it's so much better to use some non-renewable fuel. However, if you need a whole system and you need to sustain it with constant energy supply, then it's so much better to replace it with some renewable energy source. So the other advantage of all renewable fuels is that their ready availability when energy demand increases suddenly or fluctuates seasonally. That it's literally the same thing that I mentioned earlier, that if you need it on some urgent basis, then very they can be very rarely used to just produce that much amount of heat or that much amount of energy in whatever form you need, be it electric energy or thermal energy. So this is basically a very simple structure of a nuclear power plant. The first one over here, this is a reactor where basically the reaction takes place. Now coming from over here, this is a network of pipes, and then this is a steam turbine network that is then connected to a shaft to this turbine, and then this turbine is then connected to a generator, which then sends it to the power stations, electric power stations, and then they are basically sent overhead lines or power lines to other usable forms. This is also another side unit, which is the cooling tower with the cooling water. Since we are using steam as a medium, it tends to get really really hot, so it's very important to cool down the net pipe network that is going back into the steam channel or into the steam reservoir, so that it remains cyclic, and instead of pumping in new water or new medium again and again, we can use the same one repeatedly or in a cyclic manner. So renewable energy sources, we've talked about the non-renewable energy sources. Now we are going to talk about the renewable energy sources. So basically, again, it's very obvious that renewable energy sources are the energy sources that cannot be exhausted and are generally non-polluting, and they are formed in form of a cyclic process. So the biggest one of them all is obviously the solar energy. The energy falling on the earth from the sun is mostly in the form of light, and in an hour equals the total energy used by the world in a year. Unfortunately, its low energy density requires large collecting devices and its availability varies, and it's not a very reliable, constant way to produce energy. Its greatest potential use is an energy source for low temperature water heating. This uses solar panels as the energy transfer device, which converts light into heat energy. Okay, so this is basically we're talking about the general solar energy, that how the energy from the sun can be converted into different energy. However, if we talk about solar cells, the the cells that basically use this solar energy to convert it into electric energy and not other form of any energy, they're made from semiconductor materials. They convert sunlight into electricity directly. A number of cells connected together, they can be used to supply electricity to homes and to electronic equipment and communication and other satellites. They're also used for small scale power generation in remote areas of developing countries where there is no electricity supply. So instead of um, making, and because there is lack of power generation units or electric power generation units or some other long-term system, uh, these solar cells can be used as a replacement for temporary basis, or as a network. They can also be used as some permanent alternative. So what happens is that solar panels convert sunlight to direct current. The inverter inside the solar panel, it basically converts this DC electricity to alternating current, and then electricity then gets to the home and then it's used in the appliances. Extra electricity gets credited into the grid, so it's basically reutilized. This is basically a solar panel diagram where it shows that there's this anti-reflective coating, which means that it absorbs all the sunlight, and none of it, or very less amount of it, is reflected back. This is a photon track, and it's a reflective coating again. Then this is basically how the semiconducting materials work inside with the P and N junctions. It's not necessary for you to understand that. Okay, now talking about other forms of renewable energy, we have a very common one which is called the wind energy. Giant windmills called wind turbines with two or three blades, each up to 30-meter long, drive electric generators. Wind farms of 20 to 100 turbines spaced about 400 meter apart supply 400 megawatts energy, enough energy for to 50,000 homes, provide provides a useful top-up for the national grid. These wind turbines, they can, however, be noisy and they may be considered unsightly, so there is some environmental objection to wind farms, especially as the best sites are often in coastal or upland areas of great natural beauty. So it's basically a trade off that, however, since this form of a system really needs a very huge area and a lot of maintenance, it does produce a lot of energy, a very sustainable form of um, energy. However, it's a trade off that the places where it's most reliable or that are optimum for this kind of energy, um, they tend to be the coastal areas or other farms, which are the best sites of natural beauty. And it's very hard to find places where the the wind level or the speed of wind is reliable as well as of high magnitude enough, and also that there is a very huge piece of that land where all of these windmills can be installed. So a lot of things are to be considered when opting for this option. Now, talking about another form of wind energy, another form of renewable energy, which is very common to that of wind energy, is wave energy. So, in this form, the rise and fall of sea waves has to be transferred by some kind of wave energy converter into the rotary motion required to drive a generator. These generators are installed underwater, and then these waves basically use uh, the movement to basically convert or run the generators. It is a difficult problem in the large scale production of electricity by this means is very unlikely. However, in remote areas where thermal power stations cannot be set up, again, this form of energy can be used for some remote usage. But small systems are being developed to supply island communities with power. So this is basically the same mechanism or the same reasoning we were using solar panels in remote areas instead of uh, having you know power stations. Third type is tidal or hydroelectric energy, the flow of water from a higher to a lower level from behind a tidal barrier or a dam of hydroelectric scheme is used to drive water turbines that is then connected to a generator. This is also a widely used source of energy in a lot of countries. Okay, now we'll be discussing very briefly how wind energy can be used to produce electricity and how wave energy can be used. So basically, in wind energy, we have very huge windmills, and they we have some, you know, they're they're obviously installed at some place where there is some, kind of reliability about the wind situation or the wind speed. So basically, the wind makes the turbine blades move, and then they are geared up with some system of couplings that or some shafts and which then connected to a generator, and then the generator helps in generating power. Same is the case with wave energy, that in both of these cases, one of them, in the first case, the factor that is causing the movement is wind, and the other one, the factor which is causing the movement is waves. In both of these cases, the amount of energy that is produced when the wave energy or the wind energy speed is, you know, significant. It can be a lot, but the main problem is that they're very unreliable. Okay, so another form of non renewable energy, sorry, is that of geothermal energy. The It's very important to not confuse it with tidal or hydroelectric energy, because it's not related to the water body or the wave movement, but it is related to the ground or the springs inside the ground. So if cold water is pumped down a shaft in hot rocks below the earth's surface, it may be forced up by another shaft as steam. So it's very easy to just imagine this, that cold water is pumped into the shaft to a medium of very hot rocks or just very hot temperature. So it obviously causes that stream of water to boil up or to evaporate and shoot up in form of steam. This can be used to drive a turbine. The shooting up stream has very high velocity. That jet of steam has very high velocity, and it can be used very precisely to drive a turbine and then generate electricity, which can then further be used to heat buildings or everything. So this is a very localized form of energy production. And then again, it's a very useful form of energy production, which is again very environment friendly, and we are just using some environmental factor to produce energy, but it's again very unreliable because the temperature or the position of hot rocks below the Earth's surface that we are basically using to heat up the jet of water, it's very unreliable to locate that. So, geothermal power stations are in operation in USA, New Zealand, and Iceland. Last form of renewable form of energy that we'll be discussing is biomass. It's very important to not confuse it with fossil fuels because it's really different. What happens in biomass energy is that it includes cultivated crops residues, not the fossil fuels that are formed because of the dead crops or the dead animals or you know uh, over a period of a million years or whatever. This is basically used. Biomasses are basically the residual parts of crops or natural vegetations or trees that are grown from their wood, animal dung, or sewage. Basically, wastage that has no other purpose to serve. So these biofuels, such as alcohol or methane gas, are obtained from them by fermentation using enzymes or by decomposing them by bacterial action in the absence of air. And then that is used to basically, it's basically then used as the same way we were using coal or fossil fuels, that in a proper thermal power unit, you burn that and then you use the steam to run the turbines and everything. So liquid biofuels can also be used to replace petrol, although they have up to 50% less energy per liter, obviously, but they can still be very useful and they're lead and sulfur free, which means that they do have less calorific value, but they are very much environment friendly and they have this huge pro. Biogas is a mixture of methane and carbon dioxide with an energy content about two-thirds of that of natural gas, which is not bad to its advantages. This is a geothermal power unit. Now, what happens is that a steam of very, just liquid water is just run into this in the opposite direction, downwards, and then the hot water or the hot rocks under the Earth's surface over this area to basically heat it up, and then obviously it just steams up and it jets outside, um, up in the upward direction. So then that steam is then converted, it's then run by turbines and generator, and then the same procedure happens. So you can see that this is very much recyclable or a cyclic process, since the cooling tower is then returning back that steam in form of liquid water. So that means that that same jet of water is basically being recycled again and again. Okay, so power stations. Now we've talked about the types of sources. It's very important to talk about the types of power stations that are used in terms of, when we're talking about non-renewable energy sources, or when we're talking about renewable energy sources. So, non-renewable energy sources, these are used in thermal power stations to produce heat energy that turns water into steam. So the basic um, way through which energy is produced in non-renewable sources is through thermal power stations, that that some energy content is being released by those fuels, and then that heat energy is used to turn that water into steam, and then that runs the turbines, which is then used to drive the generators, and it produces electric energy. If fossil fuels are the energy sources, usually coal, but steam is obtained from a boiler. If nuclear fuel is used, such as uranium or plutonium, the steam is produced in a heat exchanger. The action of steam turbine resembles that of water wheel, but moving steam, not moving water, causes the motion. Steam enters the turbines and is directed to the stator or the diaphragm on the rotor, and then the rotor basically revolves and it drives the electrical generator, and that produces the energy. Okay, so renewable energy. What are the kinds of what's the basic type of power station when we're using the renewable energy sources? In most cases, the renewable energy sources is used to drive turbines directly. That we don't need a medium like water or anything else to basically turn the turbines or move them. So the medium itself is moving them. For it can be wind in case of wind energy, or for it can be uh, the water itself in the form of waves. That is, um, the turbines that are installed underwater. So it's the medium itself. We don't need an external medium in terms of renewable energy. As explained earlier in the case of hydroelectric, wind, wave, tidal, or geothermal schemes. The efficiency of a large installation can be as high as 89 to 95%. Many of the causes loss in thermal energy power stations. Electric energy cannot be stored on a large scale but must be used as it is generated. The demand varies from the time of the day and the season. Fixed So basically, the renewable energy sources, they're very much dependent on a lot of sources. Hence, they can be reliable, obviously, but a lot of maintenance is required and a lot of pre-planning too. That is it for this topic.